important and a critical lecture, and I believe we will all benefit greatly from this session. So please share to your friends, let them come and learn. Join us to learn today. We are still awaiting our host on the call, and I really appreciate everybody that joined early. Mr. Bashir, please can you help us put on the slide now? Hello, please confirm you can hear me.
Yes, we can hear you. Good evening, Temi.
Good evening, Juliana, and welcome.
Yeah, Temi, I heard you. I'm about to do that. Thank you.
All right, thank you. Okay, thank you very much. I can see your screen now. And yes, welcome to the July SP Warrior Section July Technical Lecture. And this is the second part of understanding P&IDs, tagging your P's and dotting your I's. It's a very critical aspect in the oil and gas industry. It's needed in all areas. There's no construction that goes on without the P&ID. And today we are going to have someone who is an expert in this teaching us today. So welcome once again, everybody. Now we'll be moving over to the next part. Please, next slide. Yes, and once again, my name is Temitope Asimi, and I'll be your moderator for today. I'm excited to have you all on the call. So briefly, today we'll be running through, I've introduced myself, and we'll be having our safety briefing, our opening remark by our section chair, introduction of our guest speaker, and technical presentation, also an interactive Q&A, so be ready to ask your questions at the end of the technical presentations, our photograph session, and of course our closing remark, which will be given by Engineer Elvis. So once again, welcome. Okay, so right now we'll be taking the opening prayer, that is the third stanza of the national anthem, and I'll just be reading from my end, and I advise that we all read from any part of the world that we are currently. So, O God of creation, grant this our one request. Help us build a nation where no man is oppressed, and so with peace and plenty, Nigeria may be blessed. Amen. Pray Nigeria be blessed. So thank you. So right now we'll be taking, without wasting more time, we'll be taking the safety brief. Safety is very important, and I would like to call on Mr. Paul Alabi, to help us take the safety brief. Thank you. Over to you, Mr. Paul.
Yeah, thank you. Thank you so much, Timitope. Good evening, everyone. It's a wonderful delight to be here. And my greetings to all the esteemed senior colleagues. So on our safety moments, we all as established. So even though this is a virtual call, we need to ensure we keep everything within of distraction or disruption into the flow of the program. Then moderator facilitator would move. All right, let's ensure we use the chat button for comments and for questions. And please ensure you can still hear the fire alarms or whatever significant sound around you, even if you are plugged in with your headset. Then, like I mentioned earlier, let's be alert of our environment. If you're on the road, please make sure you're not driving, try to find a place to park and listen in. Or if you're in your house, please ensure you're in a safe place. Or even if you're at work, ensure you're safe. Then, very important thing is to ensure we maintain a very good sitting posture. A lot of people are actually battling with aches and all that because of long hours on with very bad posture. So please let's ensure we maintain perfect a good posture even while we're listening and we are locked into the program. Thank you so much, everyone. I believe we're going to have a wonderful time. Back to you.
All right, thank you so much, Mr. Paul, for that very important safety brief. Let us all adhere to it. So right now, we'll be moving on to the opening remark, which will be taken by our very own, should I say immediate past already, section chairman. So I don't think he's on the call yet. Yes, so I will just make a confirmation right now. All right, so we won't be wasting much time while we await our section chair. I don't know if Mr. Dolapo
Temi,
can give us something.
Temi, the program chair has joined, so let him just take the opening remarks and then
Oh, okay.
section chair can do the closing. Thank you.
All right, thank you. Engineer Elvis, please kindly help us with the opening remark.
Okay, good evening. Please confirm if you can hear me.
Yes, very clearly.
Okay, so I want to welcome everyone here. Today, it's another day that is quite promising. The last time we had the technical lecture on this same lecture, P&ID, it was quite interesting. So the SP usually give us opportunity and platform to be able to grow and to learn and to improve. So I want to encourage everyone here to relax, take your time to listen attentively, and hopefully at the end of this TL, we are going to have something very, very useful. Thank you very much. And let's please observe all safeties. I don't know if that has been taken. Thank you.
Yes, thank you very much, sir. And like I have mentioned, he has reiterated that we should adhere to all safety procedures that have been mentioned. So right now we're moving on to the introduction of our guest speaker, and I'll be reading his bio. Is somebody that is very knowledgeable in this aspect and will be helping us take the lecture. So today we have Mr. Matthew B. Okuro, who is a process and project engineer at NNPC Gas Infrastructure Company Limited, operating at the forefront of Nigeria gas infrastructure drive and revolution. With over 5 years of experience across the upstream and midstream sector of the oil and gas industry, he has played the key role in the rehabilitation and upgrade of brownfield assets, as well as execution of major greenfield pipeline projects, such as the Ajaokuta Kaduna Kano and Obiafu Oben gas pipeline. He also provides process engineering support for new business opportunity, pipeline tie-ins, and steady-state simulation of the NGIC gas pipeline network. Please, let's keep our virtual applause coming. It's not easy to have such a great profile. Mr. Matthew holds a degree in gas engineering from the University of Port Harcourt. He is proficient in process simulation tools such as iSpan ICs and PipeSim, as well as SQL, Python, and Power BI, leveraging data analytics to enhance operational efficiency and support informed decision making. His professional interests focus on unlocking the multiplier effect of natural gas, process safety, and delivering projects within schedule and budget constraints. He is a member of Nigeria Society of Engineers, the Nigeria Association, the Society of Petroleum Engineers, and the Society of Chemical Engineers. This is amazing, and we should notice that it also works towards budget constraints, which is very important. Beyond his professional responsibilities, Matthew is passionate about people development and community service. He serves as a church admin for CCI Warri and is deeply committed to mentoring and coaching young engineers. In his spare time, he pretends to be a mobile photographer and endures the emotional roller coaster of supporting Manchester United and explore new worlds through books. With a great virtual applause, please let's keep it coming. I would like to welcome Mr. Matthew B. Okoro to the call for the lecture. Sir, please confirm you're on the call.
Yes, I am. Please confirm you can hear me.
Yes, we can. Yes, we can.
All right.
You can
Thank you
proceed.
so much. All right. Thank you. Please confirm as well when you can be able to see my screen. I think you might need to also grant me the right to be able to do so.
Post. Okay. Sorry, please. What is your okay? I've seen you.
All right. Okay, and also confirm when you can also be able to see my screen as well.
Mr. Matthew, kindly confirm you're still on the call. Okay, while we await our speaker, I think it must have had like a network glitch. I would just like us to engage, and do we have anybody that could just tell us the meaning of P and ID in the chat box? All right, it's back. but we can keep our answers coming. Thank you, Simon Jude. Thank you for that very correct answer. Yes. He said piping and instrumentation drawing. So we should understand the reason why we are gathered here. It's not just P and I, it's piping and instrumentation drawing.
Okay, please confirm you can hear me as well as also see my screen.
Yes, we can hear you, but we are not seeing your actual screen yet.
Okay. A minute, please. I'm currently having, I had to join for my tab, so I think my system is back up. So let me just go off my tab and share for my.
All right, thank you, sir.
Apologies.
Esteemed facilitator, you can share your slides so that we can project from our own end. We can. Engineer Matthew. Temitope, confirm you can hear me, please.
Yes, we can hear you. I think he's trying to switch the devices. So.
Okay, okay.
Hello, Bash. So I think I will share my screen with you. So just help me project. Bash, please confirm you can hear me.
Okay, no problem. Good.
Yes. Please check your company mail. I'll send it via via mail. Okay, so Bash, I've sent it across.
Okay, it has dropped now, so I'll open and share.
All right, we can see your screen now.
All right. Please confirm you can hear me.
Yes, we can hear you, sir.
All right. Thank you very much, Bash, for the bailout. Okay. Good afternoon, everybody, and welcome to yet another technical a monthly technical lecture. It's a pleasure to be here once again to be able to deepen our understanding and elevate our knowledge around P and IDs. I want to also commend the leadership of SP 104 for also bringing this also together. So just from our last discourse, we were meant to look critically into piping and instrumentation diagram. And this session is meant to take on that presentation and build up on it, on what we've learned from the last time. So we're looking at understanding P&IDs. The last time we looked at tagging your Ps and looking at your Is, and today we're looking at reading to read between the lines. And so Basha, next slide, please. So this is our outline. We'll look at the introduction and also look at the anatomy, become doctors looking at the anatomy of a P&ID. They look at what are known as legend sheets and why they are very much important. And they'll look at some symbology and process control. And also, if time permits, we'll just do a little bit of walkthrough into what P&IDs actually are. And then we'll take some questions and answers. So next slide, please. So piping and instrumentation diagram, as we've established from the last time out, that they are master documents and they are very key documents in understanding a process right from the conceptual stage all the way to the design, the construction, and also the operation and also maintenance of any plant or any facility. And piping and instrumentation diagram is very much important, whether you're a process engineer or you're an operator, or you also want to also understand how a process plant works, whether a petrochemical plant, a refinery. And one of the first steps in actually reading a P&ID, this is very important, is actually being able to actually find the correct diagram. Why this is very important is because if you look at, for example, a refinery, for example, you happen to find out that a refinery can be divided into, say, 5 zones. You have zone A, zone B, zone C. And if you pick up the wrong diagram, it's just like, for example, you traveling to Port Harcourt and putting in your Google map directions to take you to Owerri, you're definitely not going to go there. So it's to be able to find the right one, because reading and tracing a P&ID drawing to understand the process is quite easy if also you also know what the symbols are. It's like driving on the road and you see, for example, 60 in a circle, you're able to know that, okay, this is talking to the speed limits. You're unable to see a U-turn, you're able to know, okay, I'm meant to make a U-turn here. Or also if you see where you're not meant to make one as well, that also guides you so that, like we say, Olopa will not find faults in that. Next slide, please, Bash. Okay, so for the anatomy of a P&ID, so what does actually a P&ID looks like? And this is very, very much important, because when we got to understand what P&IDs are, and we will also get to understand the anatomy of it, we begin to make sense of what actually a P&ID entails. And most mistakes some people do is just to pick up a P&ID and try to look at the main body without also paying particular attention to the layers of the P&ID. So the first thing is basically the drawing title block, right? And the title block is just like an ID card for a P&ID. On the title block, you're able to see very specific information as to what the P&ID sheet number is, because a P&ID can be 100 pages, right? And you're able to see how they are arranged sequentially. You're able also to see as well the revision number, because this is very much important, because during the life of a P&ID, as we've established from the previous discourse, P&IDs are issued at different times. So you have issued for review, issued for approval, and sometimes even issued for review goes through like three iterations, if I could call them that. Being able to know which is the most recent value, the most recent version, I beg your pardon, we'll be able to now be able to understand what input to be able to make from that P&ID. Also, you're able to see also the non-technical information on the P&ID, like the name of the client or the engineering company, for example, and also what that particular P&ID speaks to. For example, you will have a P&ID for a plant, one that speaks to a 3-phase separator, one that speaks to the pressure reduction skid, one that speaks to the condensate tank and things like that. And that's also important also is the revision number, right? because the revision number just basically gives you a level of reliability, right? So if you see something, for example, some organizations use something like the first revision as A, the second as B, the third as C, and just play along with letters like that. While some others use revision like revision 0, revision 1. So if I look at a revision 1 and a 0, it tells me that the PNID revision 1 is more reliable than that of revision 0 of the same PNID sheet. The next item also is the revision log, right? The revision log just basically helps you to be able to understand the stages in which the PNID is issued. Bash, please go to the next slide. In which the PNID is issued. So from there, you're able to know, oh, it is issued for review, and able to see also who also prepared it, who checked it, and who also approved it as well, and even the date in which those revisions were done. So you see that the revision block just basically tells you as to the freshness of the PNID, and basically speaks to also its reliability. The next slide also speaks to the reference drawings, because PNIDs are basically, they refer to other documents, right? They are not documents that are done in isolation, right? Sometimes these documents needs to be studied. So I'm speaking to the reference drawing list. So this document needs to be studied to have a proper understanding of the PNID. So basically studying the reference list is sometimes a prerequisite before basically studying the PNID. Bash, please go to the next slide. So from here, you're able to see, for example, this is referencing the HVAC detailed drawing, and you're able to pick that up and get an understanding. It provides more details as well. The next slide as well also speaks to the comment block, right? And sometimes for the comment block, you have what is known as holds and also what is known as the notes area. So for example, notes are basically when there are specific, special and important notes that are meant to be added in the PNID, then we'll place those in this section. And the notes and the hold sometimes speaks to doing the design phase, right? Because sometimes you're waiting for information from a vendor, right, for an OEM. And you basically, like for example, here is saying, oh, the centrifuge tie-in point for vendor confirmation. You're waiting for the vendor to confirm that, or the sizes of all the relief valves are preliminary and have to be confirmed during the detailed engineering phase, right? So basically that holds is more or less like a hold. Let's keep a pause on this. We're going to reconfirm on these details on another stage. And then, for example, when we talk about the notes as well, it just basically speaks to notes, design notes, or even operational notes, for example, that needs to be added that speaks to some applicability. So for example, when we're operating the two filter separators we have on stream, one filter separator or one separator will be closed, will not be on stream, will isolate it, and this other one would be the one we're currently using. So basically you have that captured in the notes area. And so by the time you bring all of that together, that now takes us to the main body. So on the main body is now where you now see the main elements, or what are now known as instrument identifiers. And then we'll now start going into that in the next slide. So in the next slide, we're going to see the legend sheet. And the legend sheet is very important. They're also called the master sheet as well. So basically on the legend sheet, you're able to see symbols, you're able to see tags, you're able to see abbreviations, and sometimes conventions, because if you recall from our last discussion, I did mention the fact that different organizations use different standards because there's no universally known standard. So because of that, it's very much important to go to the legend sheet. So the legend sheet is just like, for example, you're going to a very big mall. You've never been there before, right? And then normally situated in the mall is more or less like the mall map, where you're able to see, okay, the Jurassic Park is here, the water painting is here, oh, the cinema is here, and you're able to see all of the symbols that are used to depict all of that. And then it's more or less like a legend. And then that now helps you to be able to decode the map very well. So on that, you're able to see line designation, the instrument symbols, the graphic symbols, and the process equipments. So speaking of the PNID sections, which is now the next slide we are looking at, So the P&ID basically it's divided into 3 core parts, right? So the next slide, Bash. So P&IDs can be divided into 3 parts based on these item identifiers that we have spoken to. And basically, when we're speaking about the 3 parts, we're talking about the equipment specifications, the piping specifications, and the instrument specifications. Because just like the name implies, we are talking about the piping and instrumentation diagram. And the P&ID will take different forms based on the nature of the project, of the process, right? So even if, for example, an OEM or somebody designed, let's say, a refinery, no 2 refineries will look the same, right? It also depends on also the firm also that is performing the work, the design philosophy, as well as the intended audience as well. Because, for example, a client A might have an EPC contractor might be doing a P&ID for 2 different clients at the same time, but they have different preference. They have the different way in which they want their P&IDs to be captured. So as a drafter of a P&ID or a process engineer or a piping engineer, you should be able to also speak to different influence. If we go to the next slide, it now speaks to the equipment symbols, right? So we're talking about equipment layouts. So basically, we're talking about equipment layouts. Now you're able to see on the P&ID symbols, which you can also find on the legend sheet. But these symbols should have relative shape to what they look like in real life. So for example, if you look at the first item there, which is the centrifugal pump, right? It should be able to have a relative shape to what they look in real life. Also the relative orientation as well. So for example, if you're talking about a filter separator, if it's a horizontal filter separator, it should be also a relative orientation, whether it's vertical or it's horizontal. Also the position as well, the position relative to other equipment, as well as the size. So for example, if I'm using, say, if I have a valve, a 8 inches valve, for example, that is connected to, say, a separator, if I'm drafting the P&ID, I should be able to see that valve on the separator. It should be very small, right? I will not expect to see the valve as big as a big vessel like the separator. The same thing as well. I will not see the separator as small as the valve. So it speaks also to the relative size. Then the equipment status, you're also able to see on the P&ID the status. Is it existing? Is it a feature plan? Is it a proposed plan? Or also is it also a vendor scope? The next slide just speaks to the equipment identification, right? So on the P&IDs, we have different type of equipments. Next slide, Bash. We have different type of equipments on the P&ID, so we're able to identify them. So one of the ways we can able to do that is with the equipment prefix, right? So basically, it basically shows the type of the equipment. So depending on the standard that is being used, right? You can now able to see something like a storage tank, for example, they can decide to use the storage tank and call it V. And sometimes someone will be thinking, oh, why didn't we use T for, or even S or ST? So, but it's now on the legend sheet, you're now able to see all of these things. Now, also on that equipment identification, you're also able to see what is called a tag root numeric, which basically gives a specific number to the equipment. So for example, if it's a storage tank, you now see something like storage tank V and dash 4001, 4002, and on like that it goes. Some might decide to call it V/001. Some can start it in 4 numbers, right? And sometimes as well, also have what is called tag group alphabetic. So sometimes when there is more than one equipment, especially when they are performing a single operation. So for example, I have like a separator, right, that is performing the same operation. One is in active mode, while one is like a redundancy, one is in standby. Why I can activate the one in standby to become active and bring. So in that case now, you now happen to have more or less like an alphabetic attached to them to just show the pairing configuration as well. So on the equipment on the right-hand side that speaks to the, on the diagram rather on the right-hand side that speaks to the equipment identification, you're not able to see the notation. So for example, you see the system code, right? You see the location code. So sometimes they might have five sections of the plant and they call the first one 100, they call the second one 200, 300, so that when someone says, oh, the let's say the storage or the PSV in plant section 200 and so number, or the tank, right, is overfilling. You're able to know where exactly it is. You're able to also know the sequence as well. Next slide, Bash. All right. So we're going to we're done with equipment. So we're now going to piping. And so basically piping is shown in a logical manner for sake of time. Basically, when you're talking about piping, you're talking about the various categories, whether drains or vents or flush connections, also reducers and relief devices. So next slide, we're now going to the piping and we'll talk about lines, right? So one of the things, next slide, Bash. One of the things also you also find out from a piping and instrumentation diagram is also the line symbols. Bash, please go to the next slide. The piping and the line symbols, right? That basically use symbols to represent the various types of lines. So basically on a P&ID, you will see various type of lines. We've not been able to actually identify what those lines represent. So for example, you have what is called process lines, right? So they are represented by a heavy solid line. And then they basically represent the main line, right? And also, you also see, for example, what is known as the pneumatic line, right? So pneumatic just basically, you're talking about air, right? So basically, the pneumatic line, you see a line with two double and slanted dashes. And also, as well, you also see what is called the process connection or the instrument supply, right? The process connection. Basically, they are not as solid as they are not as solid and heavy as the piping or the process line, but they're also a solid line and that is not as heavy. That basically shows how instruments are sometimes connected to even the main piping line as well. So basically you have the process connection lines, basically short pieces of lines that connect your pipeline to, say, a pressure gauge or a pressure transmitter as well. Then you have what is also known as the electronic signals, right? That basically represented by a very thin dotted line. And then you have what is known as data link, or sometimes called internal system links as well. They are basically cable connections between different computer components. So for example, something like what is called as your remote terminal units that are connected to your programmable logic controller, your PLC. You're able to do that connection through your data link, and they basically send information and data and commands back and forth. So if we go to the next slide that speaks to the line and the line fitting symbols, right? So basically also you see fittings also that speaks the line fitting symbols. The next slide, Bash. Yes, the line fitting symbols that basically common pipeline symbols, and also on the P&ID you're able to see this. So for example, to pick something, you see something like, say, a reducer, right? Either a concentric reducer or an intrinsic reducer that basically tells you that, oh, see, what we have here is a size reduction. We are going from, say, size 6 inches to 4 inches. And this is very important doing hydraulic calculation and also in construction for piping and civil engineers. So also you also see spades, you see spectacle blinds, you see strainers and filters, and other the wide strainer and also the steam strap. So these are all line fittings you're able to see on a legend sheet or also on a P&ID. If you go to the line slide, which is one of the very much important information one needs to be able to glean from a P&ID, is the service designation, right? So basically, the line identification rather. So every line on the P&ID represents a unique number, so that at any given point in time, you can be able to identify that number either during design or even they can also be referenced in operational procedure, so that at every given point in time, it's just like as each and every one of us here has a first name and a surname and also a middle name as well. So a line also has a unique number that is assigned to every line. And on that line, for example, you see, for example, the service designation. What type of fluid is flowing through that pipeline? Is it a process gas? Is it instrument air? Is it nitrogen? You're able to see that as well on the P&ID. Also, you're also able to see the pipe size, right? That's the outer diameter of the pipeline. Oh, is it 12 inches? Is it 18? Is it 20 as well? right? Or you're also able to see also if it's also in nominal pipe size, that's in mm. If it's not captured in inches, you're also able to see that as well. And also as well, you're also able to see the pipe, what we refer to as the piping class, right? The piping class just speaks to the pressure rating, right? If it's a class 600, class 900, class 1,200, even class 150. So for sake of time, these are all information that you're able to find on the legend sheet of the P&ID. The next item is the line continuation. So on this is very much important because, like I mentioned, for a refinery, you can have like 100 P&IDs, right? Different sheets. And it's very important to be able to see how the connection, how it flows from one sheet to the next sheet. So you're able to see how that flow, that, okay, this line is started from P&ID 1, but the next time we're going to see it again is in P&ID number 5. You're able to see how that connection is made in your P&ID as well. If you go to the next slide, Bash. So one of the very important diagrams you're able to find out on a P&ID is valves. And basically, valves helps you to be able to direct, to control flow in a pipeline, right? You can either open or close a valve, or partially obstruct the pathway, what is known as throttling. So the diagram on the right-hand side, you see the different type of valves, whether it's a gate valve, it's a ball valve that is used for on and off, or a gate valve that is used for throttling. So it's very important to be able to study this and able to know, so that just by looking at them, you're also able to discern what they basically do speak to. The next slide speaks to the failure modes, right? Because in normal operations, right, there's what is called failure mode, right? So sometimes your valve have what is called actuators that help you to be able to automate your valve. In the event that, let's say, let me use an example. You're going into, say, a hotel, and when you get to the hotel, the door just opens of its own accord because there's a sensor there that is able to sense that movement, someone is moving towards the door. Now, they can be able to design that door in such a way that in the event that there is loss of power, right, NEPA decides to NEPA and power goes off, right, the manufacturer can say, okay, in that case, let the door just slide open instead of remaining in a short position. So in that kind of scenario, we can say, okay, the failure mode of that door is fail open, right? So in fail close, it goes to the fail position. In fail lock, for example, it will maintain its last position if it was in close or open. And in the failure intermediate is also the valve failure is unimportant, and the rest position is also undetermined as well. And the next slide just basically speaks to the actuator, right? So basically you have actuators that basically just speaks to, so when you're talking about a control valve, is a combination of a valve and actuator. And these actuators can either be a diaphragm, it can be a piston, it can be motor operated, and it can be a solenoid. So you have the driver types listed by the table. So basically what when you add actuators to your valve, it allows you to be able to do remote operation. So I can stay in a control room, I hit on a button and a valve in the field closes. And the drivers can either be instrument air, like I've explained. So this also is very important to also see these symbols and understand what they mean. The next slide just speaks to the instrument symbols, right? We're talking about equipment symbols. It's now important to look at the instrument symbols as well. So we're talking about instrument identification, right? So we've explained, sometimes we have prefixes, they can be first, they can be one letter, second letter, or third letter. And sometimes you also have tag numbers as well. And like we mentioned, the alphabetic, if there is a duplicate, and then the item location. So if you look at, for example, the diagram at the bottom right corner, you're going to see, for example, we have XYZ 1, 2, 3. So the XYZ just basically tells you what type of equipment that is, what it is, right? The circle in itself tells you that, see, this is mounted in the field, right? And it's close to the operator. If you want to be able to read, you have to go to the field to do so. While the solid line just basically tells you that, see, it is mounted in the control room. You're able to see it. It's accessible to the operator. Why, if you have dotted lines, right, it just tells you that it's mounted out of sight. So what basically this just helps to inform you is that either it is board mounted, right? So it is invisible. These are instruments that are mounted behind a control panel. So you're not able to also see that as well. If we go to the next slide, the next slide just speaks to the instrument naming rules, right? So sometimes you happen to see the first letter that talks about the type of process variable. So for example, you have P for pressure, you have T for temperature, you have L for level, and you have F for flow, for example, for flow rate. And then you have succeeding letters that are basically used to represent the function of the equipment. Or sometimes also, I think they're also used to also represent, to modify the meaning of the first letter. So for example, if we go to the next slide, I've tried to put together something. So for example, we have what we are trying to measure is pressure, right? And so if we have PC, we have a pressure controller. If we have P and we have I and we have C, what we have is a pressure, right? The next letter is an I, is an indicator. The next is a C, is a controller. So we call it a pressure indicating controller. The same thing for LG is a level gauge, and on like that. We can be able to now make sense of what it's all about. Basha, the next slide. Okay, so I just felt necessary to just chip this in concerning equipment control, because process control is very, very important in every process industry, right? The very basic loop. So not to also bore us with so many technical details. So the very basic loop. So basically, the main function of a process control is to ensure that a plant runs smoothly and within specification. You don't want a situation where you have what is called a runaway operation, right? For example, just imagine a scenario whereby you're pumping water at home and all of a sudden the tank is full, but you're unable to turn off the switch and it just keep on overflowing. That will be a very abnormal situation, which nobody. So basically, because we want to ensure that the plant runs smoothly, one of the ways we do this is by using control loops to measure certain parameters. So there are certain parameters with targets. Okay, I want to measure pressure. But if I want to measure pressure, okay, so what now happens? I want to be able to compare that pressure against a set value, right? And say, okay, when it gets to this value, what now? Okay, what happens? For example, in our homes today, we have more or less like solar panels that are connected to pumps. Once it hits a certain level, the tank is about to get filled up. The switch just switches off power, and then the tank, sometimes the tank doesn't even overflow, right? That is basically a process parameter. So for example, you have the first, so there are first three levels of control. Basically, it has a sensing part, it has a comparing part, and it has a correcting part. So the sensing part, the sensing element, for example, basically measures to ascertain a process variable. So for example, like I mentioned, what we want to measure is pressure. So it basically measures that process variable, and then it converts that value into an understandable form. So for example, in the case of either a thermocouple or a orifice plate or a transmitter, right, is an example of a sensing variable. So for example, the transmitter will send the measured value to the control cabinets, so to allow the operator to be able to control and monitor the process. And then we have the next element, which is basically the control element or the comparing variable, which basically compares the value of the process variable that the transmitter has sent and compares that against a desired set point. So for example, the pressure on the line is 40 bar, the set value is 60 bar. So basically what the compare element does every second is basically to compare, okay, is it 40 now? Is it 60? Has it gotten to the set variable, right? And so basically it compares how far off the process variable is from the set variable, how long have they been apart, and also tells us how far they are moving towards and closer to one another. The next variable is what is called the final control element or a correcting variable. So this just basically brings the process variable closer to the set points. And basically sometimes we have a control valve, for example, right, that basically says, okay, if the flow has gotten to certain level or the pressure has gotten to certain level, close the valve by 50%. So all of that is just a basic control process that we're able to see on the process variable. So just bring this to life, but just go to the next slide. Okay, so this is just basically what I've tried to explain. So basically you have this line that's going from left to right. You have your flow element, right, which is an orifice plate that helps you to be able to sense flow, right? And then you have your so basically fluid flows through the pipe. The orifice plate, what it does is now to sense that flow. And then you have your flow transmitter 101 that basically converts the flow that has been sensed, that has been generated by, that has been sensed by the orifice plate. It converts that from the flow. So if you remember when we were looking at the lines and we talked about instruments, we talked about the electrical signal, right? It converts that to electrical signal. When the signal goes to the FIC, the FIC is the flow indicating controller. That's 101, which by the straight line, it's on the control panel, right? The operator can be able to see that. When it goes to the controller basically compares that with the set points, and it does that continuously. So the controller now sends an output signal. The output signal now converts that electrical signal, that is FY001, now converts that electrical signal to an air signal, to a pneumatic signal that basically controls the control valve to adjust its opening, and then the flow basically flows through the control valve. As you're able to see from this, the control valve is in a fail open position. So in the event that it loses instrument air from this FY0101, what happens is that it's going to fail open. It's going to remain in the open position, and then this fluid basically changes. So it just repeats this process over and over again. So I wanted to add a slide that just basically walked us through to pick up a very basic process deliverable, a very simple P&ID, and just basically walk us through and see how all of these things now come together to be able to help us to read the P&ID. Thank you very much.
Thank you so much, sir. Thank you very much for that enlightening session. I believe we've learned a lot, and we have our questions. So we'll be moving on to the question and answer session. We've heard so much about the P&ID, the line construction, valves, failure modes, equipment symbol. And yes, please, let's keep the applause coming. He has done a very great deal in explaining what the P&ID does and how it works. So right now, I know we have questions. So please, you can drop it in the chat box, or you can raise your hand, use the hand button, and then you'll be called on to talk about your question. So I look forward to our questions. Okay, I can see a hand. Okay, so we'll be giving the next 5 minutes for questions. And I can see some people saying we need the materials. Yeah, so the slide would be shared. Mr. Matthew, confirm you can share this slide.
Oh, absolutely. So I'll drop it. Let me try to drop it on the chat box so that everybody can have access to it.
All right, thank you very much, sir. I'm still looking forward to receive to get our questions. Okay, so there's someone Monday Amata requesting for the training materials. Okay, this will be shared. The last one was shared, and this one would also be shared to us. Okay, yeah, Ifeoma Lucy, you can go ahead to ask your question.
Okay, good evening, everyone. Please confirm you can hear me.
Yes, we can.
Okay. First of all, I want to thank our speaker for this insightful lecture. I actually understood quite a lot of things because I'm doing a training on instrumentation and control. So the part that I wanted him to just like touch a little is that loop where he was talking about control, like from the sensing element down to the final control element. If you can touch that part again. Thank you.
Mr. Matthew, please confirm you got the question.
Yes, so I'm supposing she wanted me to touch on the process control, right? Is it with
Yes.
the example that was provided or the basic concept of the control? Apologies. So my attention is needed in the plant. So I might just be able to just spare about 5 minutes.
Okay. So Lucy, did you get what you wanted?
Yes, like where he talks about the basic loop. Yes.
Okay.
Yeah.
All right. So Bash, if you could just help share the basic loop. So basically, like I mentioned, the basic loop basically is made up of three elements, basically three parts. Bash, if you could just share the process control. So basically, you have more or less the sensing elements, right? And the sensing element just basically measures. It just tries to ascertain the process variable, and then it converts that to an understandable form. So, for example, from this example that is presented here, you have your flow element, which here is an orifice plate, right? So basically, what the orifice plate just does is to measure, and then to measure the process variable, and then convert it into an understandable format. So then you now have more or less connected to that flow element, what is known as the here is called a flow transmitter. That now basically sends the measured value, what has been sensed, right? What has been measured. It basically sends that as a form of electrical signal, right? So it sends that, if you see with the dotted line, it sends that as an electrical signal to the electronic controller, in this case, FIC 001, right? It basically converts that flow that the orifice splits have sensed, and it converts that to an electrical signal to the electronic controller. Now, when the signal goes to the electronic controller, which is now the comparing variable, it does two things. Number one, it basically compares, what it has gotten, number one, it compares that against a set point. Oh, have we gotten to the set point? Yes. Have we gotten to the set point? No, I will do nothing. Have we gotten to the set point? Yes. Okay, I will open the control valve more, or I will close the control valve, right? So when for example, it has gotten to that set point where the electronic controller is now meant to act, it now basically sends an electronic signal to the transducer, right? So the transducer is the FY0101. The transducer will now convert that back, because you can't use electronic signal, for example, to control a control valve. So it now basically controls that, changes that to, it depends on the configuration anyway, it now changes that to a pneumatic signal, right? And that basically adjusts the opening of the control valve. So basically, it can either fail, like here, it can either open it or closes it. So the failure mode, like I mentioned for this, is fail open. I in a nutshell, I hope that's clear. Faith, I think.
Okay, Lucy, confirm you got that.
Lucy, apologies.
Yes, thank you, sir.
All right. So just one more question before you go. Okay,
All right,
so
please
this
go
is the
ahead. Yes, please
question.
go ahead.
Yeah, so the person said, I got a link from a friend status and would like to know if there are provisions for someone transitioning to technical position at work. So probably the question is if it's possible for him to transition to a technical position.
Okay, so I think the first and foremost thing to work in a technical role, at least applicable to Nigeria here, is being able to have an engineering degree, right? And basically, engineering degree just basically speaks to 5 years of undergoing engineering trainings in a certified in an institution that has current certification, basically. So I think the first and foremost thing actually is actually to be an engineer, right? But with respect to understanding a P&ID, I think anybody can pick up that skill. But as working in a technical role, first and foremost, I think first and foremost you need to be an engineer to also be able to do that, because the engineering field is a very is a very safety conscious field, and want to ensure that professionals working in that field have the requisite trainings and the rigor required and the rigorous trainings required to be able to ensure that safety is of most priority. Thank you.
All right, thank you very much for that response, sir. So I'll just take one more person. I think we have Michael Ereko Sima. Please, you can proceed to ask your question.
Yeah, good evening, everybody. Thank you to the facilitator. Please confirm you can hear me.
Yes, we can.
Okay, Sir Matthew, thank you so much. So my question on this quickly is the part for the legend sheet. I've seen a couple of P&IDs that don't come with legend sheets, a lot of them. So when I see those sort of things, are we to assume, or the plant or facility owners, are they expecting that whoever looks at this should be able to decipher what's going on based on experience from or knowledge from past facilities or knowledge with P&IDs in general? That's the first question mark I'm having. So if I'm to take it again, is a lot of P&IDs I've seen do not come with legend sheets. So are they expecting that we should know what those symbols stand for? Then my second question is, I've seen a couple of PHAs or sessions online, and then you see them deliberating on, okay, why should we have this instrument here? Why should we have a control valve here? Why should we have a manual valve here? So that decision, does it come with time, with experience, or it can also be learned? Why should we have this particular, say, spectacle blind here? Oh no, we should not have it here. That sort of thing.
Okay, all right. Thank you very much for your question, sir. So to answer the first part, all right. So in the first part of the last presentation, which the P&ID 1.0, I think it can also be accessed on the SP Worry section 104 YouTube. So for those that were not available, can also catch up with that and get to also learn. I think that's very, very important. Right. So with respect to legend sheets. So for some P&IDs, what actually the drafters do is to embed the P&ID in the main body of the P&ID itself, right? So for very small projects, right? I'm just doing a modification sometimes, or I just want to connect a time point to very small projects. Is embedded in the main body, just some little diagrams. While some very elaborate projects as well, that the drafter is concerned about quality, and also the company also, right, the clients that have given that project to an EPC contractor to be able to develop those deliverables. Some of organizations of which NGIC, which I work for, basically have set down requirements or guidelines that will basically give to drafters of our P&ID and say, this and this are what we're expecting to be able to see on our P&ID. It's also very important to note as well, I think, is when I was talking about the equipment identification, I did mention on the fact that there's also the relative shape. So for example, if I see an item on a P&ID, I can be able to infer what they actually mean based on what they look like in real life. So for example, if I see a vertical tank, for example, just looking at the tank, I can be able to know that, okay, this is meant to be a vertical tank. So this is what actually it looks like in the real life. So that helps me to be able to do that. But if it's something that you're in charge of, you can also request that legend sheet are also provided so that there's no ambiguity as to what equipment also represents. Now, with respect to the PSH you made mention of, right? So it depends on what the drafter or what the engineers or the process engineers, they're also trying to achieve. And that's also why the PSH is also there. That's why, for example, before you also go into construction, you have what is called a hazard, right? A hazard operability, where basically you bring an external party. So an EPC company has drafted a P&ID, right? A client have reviewed, But then again, they bring an external party that now basically reviews that P&ID to ensure that all of the hazards have been properly taken care of. So I give you an example. So for some of metering stations that have the opportunity to visit, you will find out that, for example, you have a manual valve that is placed at the inlet into the station. And then you have, for example, after the inlet, you have what is called an ESD, an emergency shutdown valve, right? And normally you now have an equalization line, for example. Now, in some facilities, you happen to see that equalization line being more or less like connected after the manual valve, connected across the ESD, right?
Yeah.
More or less like doing a bypass of the ESD. Meanwhile, what the ESD is meant to provide is in the case of emergency, you just hit the ESD. The ESD shuts down and shuts down the entire plant. But so for some cases, operators will say, okay, we know that this is the intent, but we've noticed that from time, it's important, for example, when we want to do like what is called a black start, we want to start up a plant, right? We can now use the equalization line across the ESD now to quickly maybe bring up the instrument, and then be able to open the ESD. Without that equalization line, we're unable to do that. So it basically decides on the design intent, right? And doing PSH like that, all of these considerations are placed on the table. They look at it and decide the best way going forward.
Okay, thank you so much.
You're welcome.
Okay,
All right,
thank you.
apologies, Semi. So I have
Yeah.
to run. Yes,
Yes.
my attention is needed. So I don't know. I will share the presentation slide with Bash. I don't know how you will be able to communicate that to everyone. Thank you very much. I appreciate it.
All right. Thank you very much for your presence and the knowledge shared, sir.
Temi, if you're speaking on a muted mic, please.
Oh wow. Thank you so much. And I hope you heard me when I said thank you to our speaker and for the knowledge shared.
Yeah,
we
we
did.
Okay, so now we'll be moving on to the next thing on our agenda, which should be the closing remark. Kindly help us put up the slides, sir. And yes, you can connect with our speaker on LinkedIn with his name, and the slide would be shared very shortly. Okay, right now we'll be moving on to the photograph session. Yes, so please, we'd like to see all our beautiful faces. Kindly turn on our cameras. Just, Mr. Bashir, please kindly help take this session. Please, let's turn on our camera. It's a good thing to know you attended. We just want to see your beautiful faces. Mr. Bashir, please confirm you are trying to get that.
Yes, I'm trying to get that.
So I can see someone requesting for the recording. It's available on the SP Worry YouTube channel. So you can just search for this session and you would get it. Have you been able to capture the pictures, sir? Hello, Mr. Bashir, please confirm you've taken the pictures.
Yes, yes. Thank you.
All right, so we'll be moving on to the next.
Can you still see my screen?
Okay, yes, we can see you, not your screen yet.
Okay. So,
Okay, yes, we can see your screen now.
okay, can you hear me? Confirm you can hear me.
Yes, we can hear you.
Alrighty. So, this is just a brief section to remind each and every one of us. Some of us are already registered members, while some of us are yet to register, or some of us are students, we've graduated, we are yet to do our transition into YP role. So SPE, with the mantra of solutions, people, energy, is a great platform for all oil and gas professionals, or those professionals working in oil and gas. It's a place for everybody. And SP section 104, worry section, as we all know, worry no they carry last. So it's a very great section to be part of. So we encourage our already registered members to continue with the membership. If your membership have expired, you should try and renew, while those that are yet to register should please go ahead and register. It's very, very easy. You can reach out to the section secretariat, or you can go ahead and do that yourself on the SPE website. Thank you very much. Temitope, over to you with your moderation.
All right, thank you very much for that. So if you've not joined SP, this is an opportunity for you to join SP today. And next up, we'll be having our closing remark, which is interchanged to be taken by our section chair. I do not think he's on the call currently, so if Engineer Dolapo can just help us with the closing remark.
Apologies, Temi. I think I've seen the incoming programs chair, Engineer
Okay.
Dennis. If you can take the closing remarks on behalf of the section chair, or if he's not available, we can have Dolapo. Thank you.
Okay. You mentioned Engineer Elvis, right?
As the incoming programs chair,
Okay.
Dennis HTML.
Okay. Okay. Good evening, sir. Please confirm you're on the call. You could kindly uptake the closing remarks, sir. Hello. Good evening, Engineer Dennis.
Okay. We'll call in Dolapo, please. Let him just help us.